Today we're going to be talking about writing and graphing inequalities. So we need to make sure that we have some vocab to start. So inequalities are not the same thing as equations, right? Inequalities would be equations that are actually not what? They're not equal, right? So can you guys give me some examples of things that are not equal? This is not a hard question.
3 and 4.
3 and 4, how are they related? So we're going to use inequalities to relate those. So 3 and 4 are not equal. So you would not say 3 is equal to 4, right? You can't say that. What would you say? 3 is less than 4, right? So that would be called an inequality because, well, it's a statement saying that things aren't equal, right? That's what an inequality is. So we have some vocab. An inequality is a mathematical sentence that contains those symbols, right? Contains those 5 symbols. Less than, greater than, less than or equal to, greater than or equal to, or not equal to. The not equal to symbol might be new to you. It looks like an equal sign with a slash through it. Is there anybody who can read this out loud? Kobe?
3 greater than X.
You read from right to left. In English, we typically read from left to right. Try again.
X lesser than 3.
Oh.
X less than or equal to 3.
Good. The word that you're missing is the word is. X is less than or equal to 3. Remember, it should be a sentence, right? So it has to have a noun and a verb. The noun would be X, the verb would be is, right? Isn't that a special word, like special name? Do you guys know about verbs and nouns yet? Isn't is a special kind of verb? It's like a, I don't remember.
Oh, it's
No.
like an action verb.
I don't remember. Is a verb. I just don't remember what.
Linking verb.
Yeah.
I don't know. Is that a thing?
Yeah. I
Linking
think
verb?
that's what it is.
Okay. Cool. I'm gonna ask. We'll ask Mr. Brobiak later. We don't need to know now. It's all good. All right. And to find a solution to inequality is any value that makes an inequality true. In fact, what's going to happen is there's going to be a ton of answers. There's going to be a ton of answers. So, what's something that makes this true? Give me a number that X could be.
2.
Sure. 2 is less than or equal to 3.
Yeah.
Luke. 1. What else?
I don't know, like
-2.
2.
3. Did you guys catch that one?
Yeah.
Why is 3 a solution to this one? Less than or equal to, exactly. So we're gonna have numbers like this. And every negative number, right? It'll start at 3, 2, 1. In fact, would 2.5 work?
Yeah.
Would 2.5 repeating work?
Yeah.
Would 3.5 work?
No.
No, because it's 3.5 less than or equal to 3. No. All right, so we've got to have a little tenderness. You guys know that song?
Like no.
You got to. Anyway, here we go. So we've got some symbols, we've got some meanings, and some drawings. Let's get these into your notes. So you've got to get the less than symbol. That means less than. So you write down those words. The graphing symbol, okay? The graphing symbol, that's an open dot with an arrow to the left, okay? So I know that I accidentally had these flipped. I apologize. One thing you might do in your notes is just switch the headers. You know? So I apologize for that. The headers on the notes look funky. So sorry. You might just want to switch the headers. Have the first header be symbol meaning. Have the second header be graphing symbol. The second one means greater than, and it's an open dot with an arrow to the right. Yeah, you'll notice that I have the headers switched on the notes. I apologize for that. Then you have your less than or equal to symbol. That's like an arrow pointing to the left with a line under it. You guys may have heard about the alligator that eats the larger one. Yeah, I've drawn the teeth before. And these symbols are why in our equations we switched the x and the variable. So that way the x or our not switch the x to the variable, made sure that the variable came first in our answer because of these things. You have greater than or equal to, it's a closed dot with the arrow to the right. What do you notice about the arrows to the right and left compared to the symbols?
Filled in.
You see a pattern? Ashley?
Whatever way the symbol's pointing, the arrow goes that way.
Good, and that is only true if the variable comes first. That's only true if when you write your inequality sentence, your variable comes first. Did you hear what she said? She said whatever direction the arrow is pointing, that's what direction the arrow is pointing on a graph. The only one that that's not true for is the not equal to. That's an open dot with arrows to the left and the right. So for instance, it's saying like x cannot be equal, x is not equal to 4. Give me a number that x could be. If x is not equal to 4. 5. 3. Notice how you can have answers to the left of that number or to the right of that number. What about 4.9? What about 4.1? Yeah, is that 4? No, it's not. So an open dot means everything except that. It does not equal that symbol. A closed dot means it will include that number in the solution. So talking about solutions, let's identify what the solutions are. Okay. So which of these numbers is a solution to this inequality? We've got a list of numbers, and you should have it in front of you. X is, how do we read that? Anna, how do you read that? There's only one, Anna.
X is less than or equal to 2.
Good. So which of those numbers is our solutions? 8. What do you mean all? You got 2. 5 is not less than or equal to 2.
0.
0 is less than or equal to 2, so we have, and then there's one more.
3.
There's no 3 in that list.
Negative 3.
Negative 3, because is 3 less than or equal to 2?
Wait, what?
Is 3 less than or equal to 2? Is negative 3 less than or equal to 2? Yes, it is. Okay, so our solutions would be negative 3, 0, and 2, so we can just write those down. All right, now our next one. Luke.
X is greater than -5.
Perfect, well said. Give us our solutions. You from this list?
3
Yep.
and -5.
Negative 5 is not greater than negative 5. So, and did you guys catch that? Why is negative 5 not greater than negative 5? Because negative 5 is equal to negative 5. So it can't be greater than and be equal at the same time.
-1.
-1, yes. So when we think about greater than, a better way to think about it is which one is further to the right on a number line, right? Which one's further to the right on the number line? This was a little bit trickier. How would we say this? Stephen?
2. 2 is less than x, and x is less than 7.
Good, which is also less than 7. Another way to read this one would be from the middle out. X has to be greater than 2 and less than 7. That's another way of thinking about it. Stephen, go ahead and give us our solutions. Which of those numbers are solutions?
2. 2. 4 and 5.
2, 4, and 5 is 2. So now plug it in. 2 greater than 2?
No.
Is 2 less than 2?
No.
No, so 2 won't work. Is 2 less than 4?
Yes.
Is 4 less than 7?
Yes.
Okay. Is 2 less than 5?
Yes.
Is 5 less than 7?
Yes.
Good, so which of those answers is actually it? 4 and 5.
Yes.
Okay. So when you're checking to see if a number is a solution to inequality, what do you do with it? And then what? And then see if it's true. On your homework tonight, you're going to have ones that have more than one step to simplify. You'll have to plug in and then simplify. But I think you guys can do it. Let's move on to the next part of this, graphing the inequality. Okay? So some things to look for. We've got our graph, we've got our inequality. Can someone read this inequality out loud for us? Jack, can you read that inequality out loud?
M is less than -4.
Good, m is less than -3. So what you want to do is you want to identify the shape here. Look up at the graph, look up at the table that you made up at the top. That symbol is what? Less than. So if that symbol is less than, I'm going to rotate this a little bit. Oh, there it is. That symbol's less than. What kind of dot are we going to have? It's going to be an open dot at -3. It's going to be open because is -3 a solution to this inequality? Is -3 a solution to this? If I plug -3 in for m, will it be true? No, because -3 is not less than -3. So it's going to be everything up until -3, right? Now, since the variable comes first, what direction is that pointing? It's pointing left. Okay? So which direction should our arrow point? Left as well. And this is how you can check to make sure that your answer is correct. You can pick any number on this arrow. If, when you plug it in, it's true, you have it in the right direction. So give me a number that's really far to the left on this arrow. Give it really far, really far. -20. Is -20 less than -3? Good. And when you plug a number that's not on the arrow, you should get a statement that is not true. So 1. Is 1 less than -3? No, so it's not shaded. That's how you can check to make sure you've shaded the correct way. If you've gotten in the habit of putting variable first, then Ashley's method of looking at the direction the arrow is pointing will work. It won't work if the variable comes second. All right, here's our next one. The symbol that we should look for, right? We want to identify what is that symbol, Aiden?
Is greater than 2.
Is not greater than.
Oh.
So just look at the list of things that we've made up at the top. No. Harsupin. Good. How do you know this one's or equal to? Harsupin. The line at the bottom says greater than or equal to. So, open or closed? It's closed because is 2 a solution to this? If I plug 2 in, is 2 greater than or equal to 2? Yes, it is, because 2 is equal to 2. Now, which direction will the arrow point?
Right.
To the right. Okay? Because the arrow on the symbol is pointing to the right, so it will look like that. Questions? One more, you guys do it on your own. Ready, set, go. Talk about it with your partner. Now, if you guys have to make your own number lines, you need 3 numbers. That's it. Okay? So the 3 numbers you need are the one that's given. Boom. That's the solution. You need 1 greater and 1 less than. That's all you need to write down. If you have your own number lines, that's all you need. So if you're making your own number line, I just need the number in the middle, and then 1 that's greater and 1 that's less. That's all you need moving forward. Okay? So as you guys make your number lines, we'll get that done. Now, next thing, we want to write an inequality for each situation. So we're going to need to use that table and write an inequality for it. So the first one says you must be this tall to ride. Right, Darius?
I'm short.
Oh, dang, Darius.
Oh, I'm short.
Hey, I got it. Luke will be with you, yeah.
So was I.
So you have to be 4 feet tall to ride this ride. Darius, you're 4 feet tall.
Yeah, I'm past.
I know. See, he's good. He's going to ride the ride just like everybody else. Quit being so heightist. Quit being so heightist. You must be at least, okay? You must be this tall to ride. So, what's it going to be? Can you be 4 feet tall and ride the ride?
Yes.
Yes. So we know that we're going to have an or equal in there, right? Can you be 3 feet tall and ride the ride?
No.
Can you be 5 feet tall and ride the ride? So what symbol are we going to need? Greater than or equal to. So I picked H for height. Doesn't really matter though. So the next one says no trucks over 3 tons. No trucks over 3 tons.
Oh.
Can a truck weigh 3 tons?
Yes.
Yes, it just can't be over 3 tons.
It's equal to two.
So can it be 3 tons?
Yes.
Yes. Can it be 2 tons?
Yes.
Can it be 4 tons?
No.
So what symbol are we going to need? Less than or equal to. And that's kind of the process that we're going to use. Okay? There's a table in your notes. These words mean these things. Okay? Less than or fewer than, greater than. The ones that are a little bit tricky, no more than and no less than. As you look, fewer than or less than is an arrow pointing to the left. No less than is an arrow pointing to the right. Think about it, right? Making cookies. Your mom's like, this recipe should make no more than 24 cookies. No more than 24 cookies.
Equal or greater than, not less than.
It should make no more than 24 cookies.
Less than or equal
Okay, see, no more than would be less than or equal to, because no more than would be not more than, right? Not more than could be equal and less. So when you think about no more than or no less than, that one's the one that's tricky. That one gets people a lot. So let's write some inequalities. Let's just start something. X is greater than -3. I want you're going to just write it out with your partner, and then I'll throw the answer up there so you can check it, because there's no really way for you to say what we're using, right? Because the word is less than or the word is greater than. So it should look like this, right? Did you get it?
I got
Yep.
it. I got it. Oh,
Give me like a woo when you get it right, okay? Give me like a oh when you get it wrong, okay? All right, number 10. Y has a maximum. Wait a second, maximum. That's not a word up there.
Yes, it is.
Which one of these phrases is like maximum? Which one of these phrases, because the word maximum is not up there. You might want to add it
There's
in.
no more than. No.
Which one of these is maximum, Madison? Why are you going like this?
No, but like I thought so for a second, and someone said something else.
So Lolly?
Is that most?
At most. Maximum is the same thing as at most, right? Maximum and at most mean it's the top value that it can be. So Y has a maximum of 11. You can write that symbol. Now that we know that maximum and at most are the same, it should look like this. And thank you. Everybody give us a whoop if you got it. All right. Oh, at least. Did you find that one? Did you find the words at least in your table? Right?
Whoa.
Now this one's tough because not positive is not there. But what numbers are numbers that are not positive? Negative numbers. How can we say all the negative numbers? Say,
W less than 0.
oh, there it is. Nice job, man. It's got to be less than 0. Can it be less than or equal to 0?
No.
Not positive. Okay? So it could be less than or equal to 0. There's no argument for it. But what we're looking for is the ones that are negative. If it's not positive, that means it's negative. Okay? So we could have had less than or equal to. I understand that there's an argument for saying that 0 could be included. Point 4 is no greater than x. Did you get it? Oh. Now, do you notice here the direction is different? Okay, the direction is different. Which one is the one that I prefer? The bottom. This is my preference. Because if I were to graph this, which direction would my arrow go? To the left, right? Point 4 is no greater than. That would be less than or equal to, no greater than.